Okay, let's walk through the StoveBench test data sheet. This is an example of a data sheet for upright canister stoves. We'll be developing others for other stove types as we go along, and we'll store them in this same Google Sheet file, which will be publicly available. So you guys can go ahead, visit this file, download these sheets yourself, and all the formulas and everything are in here. So basically, the way the sheet works is everything that's in a gray cell, don't touch. Everything that's in a white cell is something you're going to enter. So when I run these tests, I use one of these sheets per stove test I'm doing. And what I do is I repeat the test 2 or 3 times so that I can get good repeatability in the statistics. So I'm confident that the numbers I'm getting are actually believable. Sometimes if you run one test and something goes wrong, you end up with skewed numbers and it's not necessarily representative. So run 2 or 3 replicates so that you can get a good idea that your procedure is good and your performance statistics are repeatable. So this first field, you can type in the name of the test here. I've just done control boil test, which is the exact test that's described in the StoveBench protocol, which is linked right up here. So if you ever want to go back to the test protocol to review how to execute it, there's the link for it. I always record the ambient temperature of the environment I'm working in. This is in my office out in my garage, and it's heated, and I've got a temperature today of 20.1 degrees Celsius. No wind, obviously, and I don't have a fan running doing any wind tests or anything like that. I'm using an MSR Isopro canister. Has a net weight of 227 grams of fuel and an empty weight of 150.1. For the most part, this particular canister is the one I use for all of my stove tests because based on submitting samples, canister samples to a lab, I've determined that it has probably the highest purity of any canister on the market. And so it gives me a high level of confidence that it actually is 80% isobutane and 20% propane. So the canister empty weight, this is based on weighing several empty canisters and averaging them out. So this is what I use for the empty weight of the canister. The stove I'm testing today is an MSR Pocket Rocket 2, and there's my weight of the stove to the nearest tenth of the gram. And this is important because it allows us to determine, these values allow us to determine the percentage of fuel remaining in the canister at the end of each test, which I'll talk about in a second. I'm using an MSR Titan kettle pot and a water volume of 500 mils. So down here is where I enter the test data of each test, and I'll put a field there for notes, and I usually just note something unusual that might have happened in the test. Nothing unusual happened in these tests, so I have no notes. First thing I do is weigh the stove plus the canister, and that gives me a starting weight at the beginning of the test. And then after I run the boil test, I take an ending weight. Now, these two weights and the empty weight of the canister and the net full weight of the canister when the canister is full of fuel, those things all go into this formula out here, canister capacity at the end of the boil test. So that allows me to ensure that we're operating within the confines of the 30% to 80% canister capacity of the test, which is where we get the most repeatable and reliable results. I always record the starting temperature of the water and the ending temperature of the water. So these boil tests are performed at 7,200 feet in elevation where I live, and water boils at about 91 to 92 degrees here. So my trigger, which is somewhat arbitrary, and that's okay. If your temperature varies a little bit, it's not going to impact results that much, but I want to end the test at this exact same temperature every time. So I chose 91 degrees, which is about the temperature at which a boil gets rolling at my elevation. And then I record the boil time in minutes and seconds. And then the spreadsheet calculates how much fuel is used. This is the difference between the ending and the starting weight over here. There's that formula in here that calculates the canister capacity at the end of the boil test. I do another formula here that converts boil time from this format, minutes and seconds, over to decimal minutes here, which makes it easier to calculate the StoveBench score, which is the very last column. So the StoveBench score takes into consideration a variety of factors, including the water volume, the boil time, and the fuel consumption, and then calculates the StoveBench score as a result. Now up here we have a statistics section, and we have 3 statistics we want to look at: the amount of fuel used, the amount of boil time, and the StoveBench score. So we're calculating the average based on these 3 tests, the standard deviation, and then calculating a standard deviation percentage. And in general, for our internal testing, when we're really trying to get dialed in with our protocol, we're looking for standard deviation percentages of less than 5%. That may not happen in a home environment where you've got something like a kitchen scale that may not have the decimal gram accuracy that our scale does, or maybe a thermometer. Maybe you're using a meat thermometer to monitor your temperature, whatever. Just keep that in mind. So generally, again, we're looking for 5%. I don't really get too worked up about the percentages when I'm looking at other people's StoveBench tests, but I want to see what they are, just so I can get a feel for the variability that's in there. Okay, you can download and modify this spreadsheet to fit your own test environment. Feel free. And thanks for watching this video. I hope that this was helpful, and I hope this test data sheet and the templates we develop in the future are useful to you. Okay, thanks.